Okay, so yesterday we learned about how to predict products for single replacement, double replacement, synthesis, decomposition, and combustion reaction. So those are the 5 basic reaction types that we worked on yesterday in our lesson. Today, we're going to talk about the activity series of metal and how that affects whether or not a single replacement reaction actually occurs. And the best way for me to attempt to describe this to you is to tell you or to give you some type of analogy. So in Hollywood, right, in the movies, right, when they make a movie about high school, who is the coolest kid in the high school? The athlete. Like it's always like the captain of the football team or the captain of the basketball team, something in that, or the captain of all the teams, right? And who is the coolest female in all of the high school? The cheerleader, right? That's clearly not accurate because that's not how life works, but that's how Hollywood depicts your life, okay? Now, so in Hollywood, right, they also have like separated out and said like, the captain of the chess club is like the least cool person in the building, right? And so the issue is that what they also have always noted in those types of movies is that the captain of the football team can literally walk down the hallway at any point in time and point to any female and say, "You're going to be my girlfriend," and she will do whatever, and she will drop whatever she's doing and become the coolest guy's girlfriend, according to Hollywood. Does that sound about accurate? So the captain of the football team can do that, but like say the captain of the soccer team who's not quite up on that level can walk around and like point at some girls and maybe do that, but not point at all the girls and do that. And this sounds really sexist, but just bear with me for a second, okay? The other thing that you have to understand is that the captain of the chess club can walk around and point at no females and ask them to be his girlfriend because he's so low on the totem pole. So far, so good? So what I'm saying is that there are tiers of coolness in Hollywood, and that dictates what your reaction or what your dating life is going to be like. And we all know that the captain of the chess club like is golden anyway because he becomes the jock's boss later on in life. But the point that I'm trying to make is that, again, there's something that we refer to in chemistry that's called the activity series of metals. Lithium is the most active metal, meaning that lithium is one of the metals that when it is in the presence of other atoms is so reactive that it can't be by itself and it basically reacts with anything. Lithium is the football player, the captain of the football team. Okay? Lithium can replace any element below it on this list. So lithium can replace rubidium, potassium, barium, calcium, sodium, all the way down to gold. Okay? The captain of the soccer team, aluminum, can replace anybody below him on the list, manganese, zinc, iron, cadmium, cobalt, but cannot replace anybody above him on the list, so cannot replace magnesium, sodium, calcium, barium. Do you see the hierarchy of this list? And again, gold, the captain of the chess team, can't replace anybody, but gets replaced all the time. That's the activity series of metals, okay? Now, what I'm trying to get at here is that if we're looking at the first example here, where you have Al trying to replace copper, right? So in this reaction, you would have something like because it's a single replacement reaction. That's pretty much what we're focusing on here. So you would have B trying to replace A in this reaction. Now, we know it's a single replacement reaction, so you're going to end up, when you get to the product side, with B, Y, and A all by itself. Okay? Now, in this instance, the first thing that we have to do, because it's a single replacement reaction, is identify whether or not aluminum is cool enough to replace copper. Okay, so I'm going to locate aluminum on my list, and I see aluminum is right here, and I see copper is way down here. So because aluminum is higher on the list, it's more active on the list than copper, aluminum can replace copper in this reaction, and the reaction occurs. Now, if I'm going to do the same thing over here for the next example, if I have aluminum trying to replace magnesium, here, I locate aluminum on my list. And again, I see where aluminum is, and I locate magnesium on my list, and I see where magnesium is. And because aluminum is below magnesium on the list, aluminum is not cool enough or reactive enough to replace magnesium. So this reaction doesn't happen. It's the equivalent of taking a bucket of rocks and filling it with water. Nothing happens except the rocks get wet. So far, so good. So because this reaction doesn't happen, the reasoning for it is that aluminum is less reactive, less cool than magnesium. So as an example here, let's do a couple of these. So these are all single replacement reactions. So I'm not going to rewrite the thing over and over and over again because I think that it's pretty obvious as to what's happening here. I'm going to do it for the first one. Okay. So what we want to note here is we're trying to decide is if sodium, which is a metal, can replace zinc, which is also a metal, in this reaction. So we can go to consult our activity series of metals. Sodium, I find to be right here. Zinc, I find to be way down nearish the bottom. Well, not so down there. So because sodium is more reactive, cooler than zinc, the reaction does occur. So I'm going to go ahead and do the switching around and have Na and Cl and have zinc all by itself. Now, the next thing I'm going to do is I'm going to check and see, does zinc fall into the list of the diatomic molecules? And zinc does not fall into the list of the diatomic molecules, so it doesn't get a number after it. And then the last thing that I would have to do here is balance and check charges. So for sodium, I know that sodium is a +1 because it's in the first column of the periodic table. And I know that chlorine is a -1 because it's in the 17th column of the periodic table. I crisscross those charges down and I get Na1Cl1. I check my ratio and I see that it's 1:1. So there's nothing I need to do. I'm not going to write those ones. So then the last thing I have to do is balance, right? And in this reaction, I have sodium, I have zinc, and I have chlorine. On the reactant side, I have 1 sodium, 1 zinc, 2 chlorines, and on the product side, I've got 1 of everything. I want to make sure that I have that my sodiums are balanced. They are. My zincs are balanced. They are. So I'm going to need to add a coefficient of 2 here to make my chlorines balance. And now I need to add a coefficient of 2 here to make my sodiums balance, and then everybody's happy, like so. Tell you what, why don't you go ahead and do this particular next one here? Give it the old GHS try. Go for it. Hopefully for this one, you identified that there would be no reaction. You went to the list. You hopefully went to the list and noted that aluminum was underneath calcium. So this reaction does not occur because aluminum is less reactive. Also, you are going to be asked to explain your reasoning up above. And so in the case of this one, because of this reaction, you would say that sodium is more reactive than zinc. So make sure that you can explain your reasoning. Now, in the last example, okay, in this particular case, note that we have fluorine here trying to replace something. And yesterday we talked about the fact that like replaces like. Fluorine tries to replace another nonmetal. And in this case, fluorine is trying to replace chlorine. So here we have fluorine. I am going to write this one out to try to prove or at least support that point. And what we're looking for here to occur is the changing or the replacement of the nonmetals. And hopefully that will be the case. Now, in this case, before I get too far into it, I need to identify where my elements are or what my elements are. And there's two columns of this activity series of metals. One of them is all metals, and the other one is nonmetals. So I'm going to be looking for the relationship between fluorine and chlorine. And because fluorine is above chlorine on this list, right, fluorine can replace chlorine. So this reaction does occur. So I'm going to be left with Na and F, and then I'm going to have Cl all by itself. Now, the next thing I need to do is I clearly need to check my charges. So I'm going to do that here. Na is a +1 because it's in the first column of the periodic table. And fluorine is a -1 because it's the second column or 17th column in the periodic table. Yes, sir? Correct. The question was, can only nonmetals can replace nonmetals? And that is 100% correct. So we're going to crisscross these charges down. That was a great question. And we get Na1F1. We're going to check our ratio real quick once. And we'll see that it is 1-to-1, which cannot be further simplified. So again, note I did not bring that 2 across. Okay. Now I do have an element that's all by itself, and I need to check to make sure that element is not one of those diatomic molecules. And if I look here, Br2, I2, N2, Cl2, H2, O2, F2, it is one of those diatomic molecules, Cl, so it needs to have a 2 after it. Has to have a 2 after it. And then the last thing that we're going to do is we're going to balance this reaction here. And so, well, not the last, the second to last thing. So I have sodium, fluorine, and chlorine. I kind of did that, I guess, out of order. On the reactant side, I had 2 fluorines, 1 sodium, and 1 chlorine. And on the product side, I had 1 sodium, 2 chlorines, and 1 fluorine. So to balance this one, I'm going to start with my sodiums, which are already balanced. So I'm going to leave those alone. I'm going to look at my fluorines and see that they are not balanced. So I'm going to put a coefficient of 2 here, which will give me 2 sodiums, but it's also going to give me 2 fluorines. I need to go balance those. So I'm going to put a coefficient of 2 here, which gives me 2 sodiums and 2 chlorines. And it looks like everybody's balanced at that point. So then the last thing we have to do, sorry, I lied, is we have to explain why this reaction occurs. And in this case, we would say that fluorine is more reactive than chlorine. Okay, so that is how we use the activity series of metals to predict whether or not a reaction will occur. Questions specifically? Nope. Questions specifically about this? Okay,